Now it's time for the last video in our series on root finding. We're going to use the same problem again, but this time we're going to use the secant method. Now I've marked the two initial guesses. I'm going to just use the bracket edges as our initial guesses. It is important to note this is not a bracketing method. There is no need for these guesses to be on each side. I'm just trying to be as fair to the bracketing methods as I can by giving some kind of unfortunate initial guesses. So with the secant method, it's going to look a lot like false position at first. We're going to draw a line between the two guesses that we have, and then we're going to guess the point where that line intersects 0. That point is around x equal to 0.53. You can see that the f value is not particularly small, but is somewhat smaller there. Now at this point with the secant method, it's not properly obvious which of the two initial guesses you should keep using. There's no reason to believe one of the initial guesses is better than the other. Some people will say you should use the closest initial guess. Some people will say you should just use the second one and just trust that it's better. From this point on, we'll be into things we calculated and we'll trust that those are in fact better than our initial guesses. I've chosen to just use the second guess, which is the right bracket there at x equals 1.5. Draw a line through it and pick the point where that line intersects the x-axis. That is around 0.7, so we're getting close to that root of 0.73. Drawing a line through the two new points, keeping in mind we always use the newest 2 points, the last guess and the current guess, to find the new guess. So there we are at 0.733, and then once we start using those, we start to get too close to C, and I want you to watch the f value, the function value, as it changes rather quickly from something on the order of 3/10,000ths to something on the order of 1/3 of a millionth, very small numbers, and then just one more iteration from there and we're down in the 10 to the minus 12ths. One more iteration, 10 to the minus 16ths, we're down at the machine precision sort of level. That's it. That's the secant method.